Welcome to our educational channel from class 6th mathematics, the chapter 5, natural and whole numbers. Natural numbers and whole numbers, including some patterns, we'll discuss in this chapter. So these are the topics I'll explain one by one. Let us see. First, let us see what is the natural numbers, whole numbers. So those difference and successor and predecessor of the whole number. And next, main properties of the whole numbers based on these four fundamental operations like addition, subtractions, multiplication, divisions. What are the properties of the whole numbers we'll see. Then pattern in whole and natural numbers. Even patterns also let us see in this. First, when you come to this natural numbers, generally to counting numbers we can use as this natural numbers. So the numbers we can count the things. Okay, in the class there are 30 boys or we have 4 trees. Okay, 6 houses. Those numbers 4, 6. So numbers we can use as natural numbers. We can call it as a counting numbers also. Because to count any group we have to start with 1. Okay, if you want to count the number of students in your class. So what we should do, you have to count with number 1. So 1, 2, 3, 4, so on. So this is the system of number system is natural numbers. Right? These are the numbers used to counting purpose. They are the natural numbers. And when you come to these properties or the main basic steps for this, the first one is the first and smallest number in natural number is 1. Okay, 1 is the smallest number in the natural numbers. And largest one, the last and the greatest natural number cannot be obtained because so on. For example, if you take 90 is the largest, then 91 will be there. If it is 1 lakh, then 1 lakh and 1 crore, so 1 crore and 1. So there is no end number. That means the last and the greatest natural number cannot be obtained. Okay, so no last number, that means it can't be obtained. In fact, there are infinite natural numbers like counting of stars in nature. So it's infinite. Right? And third point is the difference between the natural numbers is 1. Difference between them. 3 minus 2 is 1. 4 minus 3 is 1. 2 minus 1 is 1. So difference is 1. The difference between the natural numbers is 1. Right? And by adding 1 to any number, we'll get the next number. For example, if you take 10 is the number, by adding 1 to this 10, then we'll get the next number. Okay, by adding 1 to any natural number, its next natural number is obtained. Okay, these are the basic steps about the natural numbers. Remember, the main thing is natural numbers are nothing but counting numbers. Okay, to count digits will start with 1. So 1, 2, 3, there is no decimals in this. Only 1, 2, 3, 4, so on. So there is no 2.1, 2.3. So no decimals, remember. Only the counting numbers is the natural numbers. Okay, even fractions like 3 by 4, 4 by 6, those are not natural numbers. Okay, decimals number not natural numbers. Okay, when you come to this like 3 by 4, so this is not natural number. 3.1, so it's not a natural numbers, right? Even the negative numbers like minus 3, minus 4, these are also not natural numbers. Only the natural numbers are counting numbers. The natural numbers are those numbers which we can count the things in nature like houses, trees, or boys, girls, students, strength. So numbers will start with 1. Okay, these are the basic natural numbers properties. Next we'll see the whole numbers and those properties, successor and predecessor, and main things the properties we'll see one by one. Now in these whole numbers, already we discussed about the natural numbers. So natural numbers and whole numbers, if you see the difference, natural numbers will denote with n. Already as we discussed, it's starting with 1, 2, 3, 4, so on, right? And when you come to these whole numbers, we'll denote with w. Along with the natural numbers, 0 is added extra in this. So a natural number along with the 0 form the collection of the whole numbers. So 0, 1, 2, 3, 4, so on. All the natural numbers are in whole numbers. Again, additionally 0. So a whole number is either 0 or natural number. We can say this. And natural numbers are counting numbers as we discussed, and whole numbers will begin with 0. Right. So when you see these properties for this one, the first one is the smallest first and the smallest whole number is 0. Okay, the first and the smallest whole number is 0. And last number in the whole numbers is not obtained because this is a infinite. As same natural numbers, even whole numbers are also infinite. Okay, the last and greatest whole number cannot be obtained. Like natural numbers, even the whole numbers are also infinite, right? And the difference between two consecutive whole numbers is 1. So difference between any two consecutive whole numbers, like 3 minus 2 is 1, 4 minus 3 is 1. Okay, so same like previous property. So difference is 1. Difference between any two consecutive means just side by side numbers. Consecutive whole numbers is 1. And by adding 1 to the any whole number, so it's the next whole number is obtained. Okay, say 3 is the whole number. So by adding 1 to this 3, we'll get the next whole number, right? That means by adding 1 to any whole number, so its next whole number is obtained, right? So all the natural numbers are whole numbers, but all the whole numbers are not natural numbers because the 0 is difference. All the natural numbers are whole numbers, but all the whole numbers not natural numbers because only a 0 is extra. That's it. Okay, the properties are same almost. Only the smallest and the first whole number is 0 and last one number is infinite. Same difference is 1. By adding one number to the whole number, get the next number. Right? These are the basic properties you remember. And successor and predecessor of the whole numbers, some basic properties including that graph line also we'll see now. In this topic, successor and predecessor of the whole number. So we should know the meaning of these two words. When you come to this word, successor is the word used the meaning for the next. So next number we can use the successor. Predecessor is the before. Okay, just remember these two words. We can answer this. So when you come to the successor of the whole number, the successor of whole number of a natural number or whole number. So it's obtained by adding 1 to it. If you add one number, then you get the next number, right? So there is a successor. So like successor of 0 is 1. And successor of 1 is 2. You can see the example. So successor is the next. So successor of 2 means after 2 is a 3 in all numbers. Because 2, 3, 4, so on. So successor of 3 is 4. Successor of 5 is 6. That is the next number. And next one, predecessor. When you come to this, predecessor is before number. So predecessor of 7. Before 7 is 6. These are the example for the predecessor. Predecessor is the before number. Successor is the after number. You remember. Now based on this, we need to remember few points. Generally, natural numbers will begin with 1, right? 1, 2, 3, so on, right? And whole numbers will 0, 1, 2, 3, so on. So if the question is asked, what is the successor of 1 is 2. Then what is the predecessor of 1 in natural numbers? So it's not possible. There is no. But in whole numbers, predecessor of the whole number, predecessor of 1 in whole numbers is 0 before. Okay, for 1 there is after and before in whole numbers. But for 1 there is after number, there is no before. So before there is no. That means the predecessor of 1 in natural numbers is not obtained. So it's not possible. You can remember. So by adding 1 we'll get the successor number. By subtracting 1 we'll get the predecessor. So let us see the number line. Some questions they'll ask to represent the number line. So in whole numbers starting with 0, next followed by 1, 2, 3, 4, so on. Here is the 0 itself is starting. So successor of 0 in whole numbers is 1. And there is no predecessor of the whole number. Predecessor of 0 in whole numbers is not obtained. It's not possible. Okay, predecessor of the whole number 0 is not possible. Predecessor of natural number 1 is also not possible. Right? These two things you remember. And represent the numbers on number line. For example, represent 4 on the number line. If you write number line, then 4 you can mark it. On the 4 you can mark it. So there is a representing. So particular numbers on the number line. Just to draw as it is 1, 0, 1, 2, 3, so on. Which number is asked to represent, that number you can highlight. So you can keep one bubble sign. Okay, these are the things. And observe the number line. In a whole number is greater than every whole number is on its left. So when the numbers are right side is increasing and left side will be decrease. Smaller than every whole number is on its right. Okay, these are the two differences. The whole number is greater than every whole number on its left. Any number you can take. For this, compared to its left number, that is a greater. Compared to its right, there is a less. Okay, smaller than every whole number on its right. So these are the things. So any number you can choose. If you take it as 2, for 2 left side number is lesser than this. For 2 right side number, this is less and this is more. 2 is the number. For 2 the left side whatever number is, this is a greater than left side and this is smaller than right side numbers. That's why the statement we can conclude like this. A whole number is greater than every whole number on its left and smaller than every whole number on its right. Okay, this number line we can observe. Okay, these are the points based on the successor and predecessor of the whole number. It's simple. Next, we'll see the properties of the whole numbers for addition, subtractions, multiplications, and division, so on. Properties of whole numbers for addition. So let us see the basic properties of the whole numbers. As we know, whole numbers from 0, 1, 2, 3, so on till infinity, right? So based on that, we have the properties. The main properties for the operations of addition, subtractions, multiplication and divisions in whole numbers, we have the common. So let us see first in addition. So first one is a closure property. According to this, if x and y are two whole numbers, then x plus y is also a whole number. So for example, 2 comma 3, we know that these two are the whole numbers. Then by adding them, 2 plus 3, even 5. 5 is also a whole number. So as per the rule, if x and y are two whole numbers, if these two are whole numbers, then x plus y. So sum of those two numbers, x plus y is a whole number again. So it's a closure property. Any two whole numbers if you take and do addition, then the result is a whole number. That's a closure property. And commutative property. When you come to this commutative property, here if x and y are two whole numbers, then x plus y is equals to y plus x. Okay. If x comma y or belongs to whole numbers, this is a belong symbol, then x plus y is equals to y plus x. It's a commutative property. Take some example. Let us take 4 comma 3 or whole numbers. Then 4 plus 3 value and 3 plus 4 value must be equal. 4 plus 3 is 7. Again 3 plus 4 is also 7. That means commutative property exists for the whole numbers for addition. Right? And next one. Associative. So when you come to this associative property, same like commutative property, here we have to take the 3. That means for any three whole numbers, let us take x comma y comma z. If x comma y comma z or belongs to the whole numbers, then according to the associative property, x plus y plus z is equals to x plus y plus z. Okay. Take an example. Let us take 3 comma 5 comma 6. That means first 3 plus 5 plus 6 value should be equals to 3 plus 5 in one bracket plus 6. Okay, check here. 5 plus 6, so 11, and 3 plus, so it's a 14. 3 plus 5 is 8 plus 6. So 14. It's equal, right? So x plus y plus z is equal to x plus y plus z is exist for the in addition whole numbers. So associative properties exist for this. Next one, existence of identity and inverse. These two also will see in this. So when you come to this identity and one more is inverse. Identity and inverse. When you come to these both, for any whole number x, say some number, by after adding to that, so you get the same number. X plus dash will get again x. Obviously, we know there is a 0. So in other words, addition, sum of any whole number or whole number is 0, then number is itself. Any number adding with 0, then number itself. So that means here is the whole number 0. So for which x plus 0 is equal to x. Same way that is equals to even 0 plus x also. So additive identity. So additive element for addition is the 0 now. Same way when you come to the inverse. So here is a, let us take some x plus dash is equals to 0 will get. X plus what number if you add to x will get 0. There is a minus x. So changing the sign is the inverse in addition. So let's take 5 is the number plus dash is equal to 0. 5 plus dash is 0, that is minus 5. Right, clear this? So minus 5 is also a whole number in this case. So in this, that means 5 plus minus 5, 0. But minus 5 is not whole number, right? When you come to this. Therefore, minus 5 is not the additive inverse of the 5. In same fact can be shown for every other whole number other than 0. So 0 plus minus 0 is 0 only. So additive inverse. So what is the other number if you add, you get 0. So these are not the whole numbers. Yes, that means if the sum of two whole numbers is 0, so that is additive identity. The whole numbers are called additive inverse of each other. Now x comma minus x. So they are additive inverse to each other by adding what you're getting 0. And the main thing is this first three, closure, commutative and associative. And when you come to this cancellation of law, we'll see once. If x comma y and z or any three whole numbers, if x plus y is equals to x plus z, then we can cancel this x either sides, then the answer is y is equal to z. These are cancellations. Same way, if a plus b is equals to b plus c, so here b we can cancel, then a is equals to c. Right? Even x plus 8 is equals to 5 plus 8. So as per the cancellation of the whole numbers, you can cancel plus 8 either sides, then x is equals to 5. Right? This is the main properties. And when you come to this some problems based on this addition, the question is by rearranging the given numbers evaluate. By rearranging, for example, 463 plus 826 plus 337 plus 274. By rearranging this, rearranging means 3 is units place. By 3, if you what number if you add, we'll get the 0 in the units place, that is 7. So these two you can take together, 6 and 4, so 10. These two numbers will take together, that's called rearranging. 463 plus 337 is one set, plus 826 plus 274 is make it as another set. Now 463 plus 337 is 800 plus 826 plus 274 is 1100. Now this total is 1900. So this is the way we can do rearranging. Just to check the units places, which two units you can add, we'll get tens, means units must be 0 again. So this is the method to rearrange the given numbers and evaluate these type of questions we can solve in this. Properties of whole numbers for subtraction. Let us see the basic properties of the whole numbers for subtraction. So as we know already, the closure property, commutative property and associative property. Along with that, existence of identity and inverse. Let us check in this whole numbers for subtraction. So when you come to this closure property, first one. So as per this rule, if x and y are two whole numbers, then x minus y is not necessarily a whole number always. So it's not necessary every time. So that means x comma y belongs to whole numbers. Every time x minus y may or may not belongs to whole numbers. Maybe it's whole numbers or not. Let us check one example. We know that 4 comma 2 or belongs to whole numbers 4 and 2. From this 4 minus 2 is equals to 2. This also is whole number. Or else 7 and 11 or the whole numbers. From this 7 minus 11. 7 minus 11 is minus 4. But it's not belongs to the whole number. That means one thing we can conclude. If x and y are two whole numbers, then x minus y is not necessary a whole number. Right? So, and that means the whole numbers are not closed for subtraction. So they're not closure properties does not exist for the subtraction. Next one, commutative property. So when you come to this commutative property, here is if x and y are two whole numbers, then if x comma y are two whole numbers, then x minus y is not equals to y minus x. This implies the subtraction of two whole numbers is not commutative. Check with example. Let us take 15 comma 8 are two whole numbers. So 15 minus 8 and 8 minus 15 is both are not equal because 15 minus 8 is 7 and 8 minus 15 is minus 7. So they are not equal. That means the subtraction of two whole numbers is not commutative. Right? And when you come to this associative property. Next one. Yeah. Associative property. Here is a three numbers. That is, if any three whole numbers, let us say x, y, z, or belongs to whole numbers, check once x minus y minus z and x minus y minus z. So they are not equal here. So that is the subtraction of whole numbers does not satisfy the associativity. Okay, even for this, let us take one example. In the place of x, y, z, okay, for x is equals to 10, any number, let's take bigger number then. X is equals to 15, y is equals to 10, and z is 7. So as per the rule, x minus y minus z is not equal to x minus y minus z. Both we can check that we get same answer or not. First, x minus y minus z, that is 15 minus 10 minus 7. 15 minus 10 minus 7 is 3. 15 minus 3 is 12. This we got 12. Next one, x minus y minus z. So 15 minus 10 minus 7. 15 minus 10 is 5 and minus 7, that is minus 2 because 5 minus 7. So here is a small number, big number is subtracting, so negative 2. They are not equal. That means we can conclude that the subtraction of the whole numbers does not satisfy the associativity. Right? And next one we have the identity and inverse. Let us check is exist or not. So first one, identity. When you come to this existence of identity for any whole number x, if x is belongs to whole number, then x minus 0 is equal to x. But 0 minus x is equals to minus x. 0 minus x is minus x. So for this subtraction, no identity number exists. X minus 0 is not equals to 0 minus x. Not equals to 0 minus x. So existence of identity. That's why subtraction has no identity number for this. And existence of inverse. We come to this inverse. Since subtraction for every non-zero whole number does not have identity number, so its inverse also does not exist. If there is no identity, then inverse also not exist directly. So there is no inverse for this, right? So overall for subtraction, when you observe, the closure property, commutative, associative, and identity and inverse or not exist for this. These are the properties of the whole numbers for subtraction. Let us see the multiplication for now. Properties of whole numbers for multiplication. Let's see the basic properties for this. And first one, let's check the closure property. So closure property is the first one. We'll let us see in this. According to the closure property, if x and y are two whole numbers, then x into y is also a whole number. Right? If x comma y belongs to the whole numbers, then even x into y or xy, you can keep the multiplication symbol. X into y is also belongs to whole number. Check the any number of the whole numbers. This rule will exist. For example, 3 comma 7 belongs to whole numbers. Now 3 into 7, so 21 is also the whole number. So closure property exists for this. Next one, commutative property. When you come to this commutative property, if x and y are two whole numbers, then x into y is equals to y into x, right? X comma y belongs to whole numbers. Then x into y is exactly equals to y into x. Check the one example. 4 comma 5 belongs to whole numbers. That means 4 into 5 value and 5 into 4 value must be same, right? Because 4 times 5 is 20, 5 times 4 is 20. So they are equal. So commutative properties exist for the whole numbers for the multiplication. And next one, associative property. When you come to this associative property, for any three whole numbers, let's take any three whole numbers x, y, z, x comma y comma z. These all belongs to whole numbers. Then as per the rule, x into y into z must be equals to x into y into z. Right? This is the take numbers now. For example, 4 comma 8 comma 10. Okay, 4 8 10 belongs to the whole numbers. Now as per the rule, first 4 into in bracket 8 into 10, this value 4 into 8 into 10. These two values must be same. Should check it. 8 into 10. So 80. So 4 into 80 here. 4 times 8. So is a 32 and into 10. 4 into 80. Same. 320. This is also 320. So it is equal. Right. So associative properties exist for this. Next we have same way distributive. We can take your own rule. And when you come to this identity and inverse, those both you check. So if identity exists only, next inverse you check. So existence of identity for any whole number x. For any whole number, if x belongs to whole number, x into 1 is equal to x. For x, what number if you multiply, you will get the same number. That is the 1. Same way, 1 times x also is x now. So multiplication of any whole number with 1 is the number itself, right? So the whole number 1 for each x into 1 and 1 into x is always x is called the multiplicative identity or identity element for the multiplication. So is the 1 is the multiplicative identity for the any whole number. Let us even examples if we take also same. Like 9 into 1 is 9. Again 1 times 9 is 9. Next identity is here is therefore identity element for multiplication is 1. Then when you come to the inverse, for x is any whole number, same. Let us take x is the whole number. Then if you x into dash, we'll get again identity. X into what is 1? That is x into 1 by x. But 1 by x is a whole number only when x is equals to 1 in this case, to make it as x as 1. So 1 by x is not whole number. For the other values of the whole numbers, if we take 1 by x is not. But when you come to this inverse, we can take it as. So for any whole number, its multiplicative inverse does not exist because reciprocal value, no, that's why. To get the 1, we need to take this. But generally, 5 into dash is 1. So 1 by 5. But 1 by 5 is not whole number. So therefore, multiplication inverse does not exist. Identity is 1, but multiplication inverse does not exist. Right? This is the basic properties. Same in this concept only, like rearrange. By rearranging the given numbers, evaluate. For example, question is 1 into 125 into 8 into 5. Instead of multiplying straight away, we have to rearrange. Just check this. Which number if you multiply, you'll get times zeros. That means 4 into 5, 125 into 8. 4 into 5 is, take it as one set, into 125 into 8. So it is 4 times 5 is 20, 125 times 8 is 1000. So finally it is 20,000. This is just by rearranging the numbers. To evaluate, you can use this rule. And using the properties, if you want to evaluate, one question. Using the properties, evaluate those properties, commutative, associative, identity, those one. The question is 497 into 351 into 10 minus 251 into 4970. Now in this question, so first of all, using commutative. So here is any number is the same or not, you can check. So just I'm taking the question like this, 497 into 10, because 4970 is there. So 497 into 10 is, next up we can write, into 351 minus 251 into 4970. This is using commutative property. Just that means x into y is equals to y into x, right? Commutative property. This first step is commutative I used. So these both exchange this 497 into 10. That means these change it. 351 and 10. If you use this property, 10 we can come this side. Now 4970 can take the common. 497 into 10 is 4970. If you take common, 351 minus here is 251. Okay, this is using distributive property. Then 4970 into 351 minus 251 is 100. So finally 4970 more 2 zeros. So 4,97,000. By just rearranging, these are the problems we can solve for this properties in multiplications. Properties of whole numbers for division. So let us see the first some basic properties of the whole numbers for division. Then we'll see the problems also based on this. So according to the rules, we have the first to see the closure property. So whether closure property exists or not for this. So in this, when you come to this closure property, if x and y are two whole numbers, so x comma y belongs to whole numbers, then x divided by y. From this, if we take x divided by y value, it is not necessary a whole number always. So it may be belongs to whole number, or sometimes it's not belongs to whole numbers also. See the example. Now, if you take 3, 6, 3 comma 6 are belongs to whole numbers. That means 3 divided by 6, that is equals to 3 divided by 6. Now it's a 1 divided by 2, 1 by 2. So it is not the whole number. Instead of 3 comma 6, if you take 6 comma 3 belongs to whole numbers, then 6 divided by 3, that is 6 divided by 3, that is equal to 2. Now 2 is the whole number, right? That means closure property does not exist for the whole numbers for division, because it may be belongs to or not necessary, no, is always, but should be always. If it is whole number, then only it exists. So closure property does not exist for the division of a whole number. And next one, commutative property. In commutative property, if x and y are the two whole numbers, x comma y belongs to whole numbers, then x divided by y value, y divided by x value. So they are not equal always, right? So division of the whole numbers not commutative. See example, 4 comma 8 or belongs to whole numbers. So 4 divided by 8 and 8 divided by 4. 4 divided by 8 is 1 by 2, 8 divided by 4 is 2 by 1. So they are not equal. So division of whole numbers is not commutative. And same way, associative. Associative property, according to this, uh, take 3. If x comma y comma z, if x comma y comma z belongs to whole numbers, so they are the whole numbers, then x divided by y divided by z is not equals to, in this, x divided by y divided by z. So this is the truth. So division of the whole numbers not associative. So you can take an example and check. So I'm not writing here, just any number, even if you take for example 2 divided by 2 divided by 4 divided by 8. Let's take x is 2, y is 4 and z is 8. Then here is the same, 2 divided by 4, then divide by 8. So that is not correct. Yes. So 2 divided by 4 divided by 8 is 1 by 2. 2 divided by 4 is 1 by 2 divided by 8. As per the rule, 2 into 2 by 1. If you keep into symbol, no, 4 it is. 1 by 2 into 1 by 8. So it's 1 by 16. So they are not equal actually. So associative property does not exist for this. So division of the whole numbers is not associative. Right? Same way, identity and inverse. So identity of the element of division of the whole number does not exist. So identity does not exist. Same way, existence of inverse. So even inverse also does not exist because there is no identity. There is no identity element for the divisions. So these two are does not exist. So finally, when you come to this whole numbers for division, closure property, commutative, associative, or not exist. Even identity and inverse also. Now let us see the problems from this. Let me explain just two questions. Let me write here. Find two-digit numbers. Two-digit numbers such that the reason is such that their product is 840. Their product is 840. The product of their units is digit is 20. The product of, let me write the question. So product of their units digit is 20, and the product of their tens. Product of their tens digits is 6. Now this is the question. Find two-digit numbers such that their product is 840. Product is 840 and product of their units digit is 20. Product of their tens digit is 6. So two numbers you have to find out. So let us take first product of the units digit is 20. Which two single numbers if you multiply 20 will come. So the rule for this, product of units digit first. So product of the two numbers is 20 means there is only 4 into 5 or 5 into 4. So 4 and 5 the chances. So unit digit. Because only single number. Single numbers multiplication getting 20 is only chance is 4 into 5 because 10 into 2 is also 20 but 10 is a double digit number, right? So only 4 comma 5 are the unit digit places. Next one, product of the tens digit is 6. So product of tens digit is 6 means 6 we can write only 2 into 3 tens place. So 2 comma 3 are the tens digit. Even 1 into 6, 1 comma 6 or 6 comma 1 we can take. But two digit number to get 840, let us take with 2 and 3 first. If it is not exist, let's go for the 1 comma 6 also. According to this data, tens is 2 and 3, units is 4 and 5. So tens place is 2. That means one is a 25 and 34. This is one chance. Or 35 with 3. Or 24 and 35. Okay, tens place is 2 and 3. So 2, 3, 2, 3, same. Units place is 4, 5. Now according to the first rule is sum of their products is 840. Here is 840. So which two numbers if you multiply 840 will come, that is the answer. So 25 into 34 you multiply, 24 into 35 multiply. 24 times, okay, 25 into 34, 850 it is. But 24 into 35 is 840. So 840 they asked, no? So the required numbers. For required numbers is 35 and 24. So this is only the correct. 24 and 35 are the required numbers. Just properties we are applying for this to get it. And normally the division rule we know that dividend is equals to divisor into quotient plus remainder. So based on that also we have the questions. If you do divisions, for example 7 divided by 2. 7 divided by 2. 2 3 is a 6 and 1. So in this 3 is quotient and 1 is the remainder. 7 is a dividend. 7 is dividend and here is a 2 is the divisor. As per the rule, dividend is equals to divisor into quotient plus remainder. Always dividend is equals to divisor into quotient plus remainder. You can check this. 7 is equals to 2 into 3 plus remainder is 1. So it is exist. 7 is equals to 2 into 3 is 6 plus 1. So 7 is equal to 7. So any division we can use this rule. Dividend is equals to divisor into quotient plus remainder. Out of this 4, if we know any 3, we can find out the third one. Okay, so based on that also we have the questions in this properties. Pattern in whole and natural numbers. So when you come to some patterns I'll show in this based on the whole and natural numbers. Generally the pattern is a arrangement of numbers or some shapes. So only the three simple pattern I'll show in this video for this topic. So first pattern is, so generally they will give two or three series and based on that we have to identify the remaining. This is nothing but the pattern in the whole or natural numbers. Simple, I'll show you. For example, 1 plus 3 is equals to 4. That is equals to 2 into 2 is equals to 2 square. Next one, 1 plus 3 plus 5. The value is 1 plus 3, 4, 4 plus 5, 9, right? And that is 3 into 3, it's a 3 square. Same way, 1 plus 3 plus 5 plus 7. This value is 16. 16 is 4 into 4, it's a 4 square. So by observing this, can you identify the next 3 without adding? So 1 plus 3 is 4, 4 plus 5 is 9, plus 7, 16. Instead of adding, just by observing, that we can make like this. So 1 plus 3 plus 5 plus 7 plus 9 means addition of the odd numbers. How many odd numbers you added? 5 odd numbers you added. That is become as 5 square because is a 25, that is 5 into 5. Now this is the pattern here. Same way, 1 plus 3 plus 5 plus 7 plus 9, next odd number is 11. So 6 odd numbers. That value exactly equal to 6 square because the 36 it is 6 into 6. Same way if you observe 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. 7 odd numbers. So its value is 7 square, that is 49. So it's 7 into 7. First 3 are given, based on that next 3 just made. This simple one pattern. Okay, C is second, one more. Just take the, these are the odd numbers I added. If the 1 plus 2 plus 3 plus 4 plus 5. Numbers addition from 1 to 5. The answer is 15 it is. By adding 3 plus 3, 6, 10, 15. Next one, 2 to 2 plus 3 plus 4 plus 5 plus 6. 2 to 6 numbers. This value is 20. If you add also, you'll get 20. Again, start with 3. Next 5 numbers. Start at 3, next 5 numbers. 6, 7, 6 plus 7. So value is 25. Now by observing, can you make the next 3 sets or next 2? Clearly, next 2 steps in this pattern will be. So what will start 4 now? 4, 5, 6, 7 and 8. Observe this 5 to 20, 20 to 25. So 5, 5 is added. So obviously next one must be 30. Then 5, 6, 7, 8, 9. If you add exactly, you'll get 35. Okay, just you can extend anything. This is the pattern. Okay, let me show one more one. Let's take the numbers. 1 times 1 is 1. 11 into 11. It is 121. 111 into 111 is, this is 12,321. So based on this, can you make next 2 or 3? So 1, double 1, triple 1. If it is 3 ones, 1, 2, 3, again 2, 1. 2 ones means 1, 2, 2, again 2 to 1, decreasing. Similarly, 1,004 ones into 4 1 means 1,111 into 1,111. 4 ones, right? So that is 1, 2, 3, 4. Again from 4 decreasing. Yeah, this answer exactly equal to this. If you can multiply and check. Same way. 5 ones if you take 3, 4, 5 into, that means 11,111. 5 ones, no? So answer must be up to 1, 2, 3, 4, 5. Again 4, 3, 2, 1. Even if you just make it 12 crores, 34 lakhs, 54,321. Not of comma, just the series is this. We can make anything. So if you know this particular pattern, based on that we can make the another series. Okay, so many examples are there in this class also. Mostly based on that previous, by observing, we can frame the next pattern using this whole and natural numbers, right? So these are the basic concepts from this topic, from this chapter. And for other topics or other videos from other chapters, Just to check the links in description below and you can go to that.